All right, so for today's class, we are going to be focusing a little bit on standard 8 NS1, which talks about rational numbers and irrational numbers. So we're focusing on distinguishing between rational and irrational numbers and determine how many numbers that are not rational can be approximated by rational numbers. So again, we're just distinguishing between what are rational numbers and what are irrational numbers. Um, Success criteria states that I will be successful when I can explain the difference between a rational number and an irrational number, and then also convert a repeating number to a simple fraction, ooh, and estimate a non-perfect square between two integers, okay? So those are three things we'll focus on for today. I'll break this video up in several pieces, so you'll have to go back and watch some other ones. But the first thing we're going to look at is just distinguishing between rational and irrational numbers. So this is like a quick example of something that I found, where you have real numbers. All right, the big umbrella is real numbers, and then it's broken down into two parts, rational numbers and irrational numbers. I'm going to pull up my whiteboard so that we could, um, there it is. So we have this big umbrella, and everything underneath that, I'm going to type it in actually, is a real number. All right, and then we're going to break it up into two parts. We're going to say that side is rational numbers, and this side is irrational numbers. Some examples of irrational numbers are, for example, pi. All right, pi is an irrational number. Oh wait, I need to switch to pen. Pi is an irrational number. 3 pi is an irrational number. It has the pi with it, so it becomes irrational. If I have square root 2, we know that square root 2 is not a perfect square. So since it's not a perfect square, then it tells me that it's irrational. Okay, this is just a brief overview going through some examples of what rational numbers are and irrational numbers are. Another one would be square root 3. Right? That one is also irrational. Or square root 10. Oh, what if I did square root negative square root 10 pi? That's irrational. Now, underneath the rational numbers umbrella, we're going to have two other ones that we're going to look at. I'm going to call this W, not I. I stands for integers. And then we're going to do one more. That's going to be W. W stands for whole numbers. Okay, whole numbers are all the numbers from 0 up. So all the positive numbers. So whole numbers are 0, 1, 2, 3, and so forth. All right, those are whole numbers. It has nothing to do with the negative numbers. Okay, nothing to do with the negative numbers, and it's all the whole positive numbers, including 0. So 2.3 is not a whole number. 2 is a whole number. 3 is a whole number, okay? And then now for integers, integers is all the negative numbers. So we have the negative numbers and the positive numbers, which also includes a 0. So let me put in that. That includes negative. I'm going to put some dot, dot, dot. So we understand that it's continuous. It's not just, so negative 4, -3, -2, -1, 0, 1, 2, 3, ... So all the negative numbers, 0, all the positive numbers. So there are whole numbers that are integers. There are integers. Some integers are whole numbers. All right. I just want you to see how all of this can overlap. Now, if we're looking at rational numbers, we're talking about all those decimal numbers that aren't whole numbers, aren't integers. So for example, 3/5. All right, we know if we put that in the calculator, it's going to give us a decimal form. -8/2. Actually, let's not put that one in there. 21.6. That's one. 3.56. That's a rational number. Okay, 2/3. We're talking about all those fractions and decimals that aren't necessarily integers or whole numbers. They could be negative as well. So we have -2/3. That's a rational number. What I want us to look at is, let's look at this one I just realized. So would you say √2? What is √2? Where would √2 fall on? Not √2, √4. Where would √4 fall under? What's the square root of 4? 2. Yeah. The square root of 4 is 2. And since 2 is a whole number, it would fall underneath the whole number category. So technically, square root 4 is a whole number because we could find it. If it was a number that we can't necessarily find the exact square root for, if it's not a perfect square, then that becomes an irrational number. Okay. So also, if you look at negative, if you do minus square root 4, that's going to be -2, which makes it an integer. All right. So again, these can come in different forms. You just want to be able to identify what the different classifications for numbers are and how we separate them.